So we're told that the regular price for admission to an amusement park is $5,500 for the adults. And I'm going to call A the number of adults, and it is $4,800 for children. We're told that there were at least 10 people, which means A plus C is greater than 10. This is the number of adults, number of children, and they get a 10% discount. So it's 90% of this was what they actually paid. Question is, how many children were in the group? So we need to find what C is. So I'll start with statement 1. It says the total admission fees paid for the adults in the group was 29,700 yen. So that's equal to the price per adult ticket times the number of adults, and that would give me what A is. But that alone isn't sufficient because we don't know anything about the number of children. Statement 2 says the total admission fees paid for the children in the group, which would be this product, 0.9 times 4,800. C is 4,860 plus this. And I need to just show that I will get multiple values for C because they are constrained to be integers. So first I need to clean this up, multiply by 10, which would require me to multiply each term by 10, so that gets rid of this decimal. I notice that this is divisible by 9. 8 plus 4 is 12 plus 6 is 18. So divide each term by 9. 9 times 5 is 45, 354. So this becomes 4,800C is 5,400 plus 5,500A. I think it is important to do this kind of a simplification. So C is 54 plus 55A over 48. Now the question is, how do we come up with integer values that would satisfy this? So the way I do it, I'll show you that method, and perhaps there are other easier ways to do it, but this is kind of how I approach this, is split this into multiples of 48 because we know C has to be an integer. So 48 plus 6, same thing here, 48A plus 7A. So I know that when I divide these terms by 48, those become integers. So that would be 1 plus A plus 7A plus 6 over 48. Now this needs to be an integer. So I'm actually, again, you can kind of guess here. So for example, if A is 6, I notice 7 times 6 is 42 plus 6 is 48. I do know that this is going to be an integer. So that would be 1. So I have one set of values. These do add up to greater than 10 because that's 14. Now how do we find the next possible value of A? So again, I'm going to call this an integer M. Let me just do it on the second page. 7A plus 6 over 48 is M. And 7A plus 6 is 48M. 7A is 48M. So I'm going to do that same procedure again, is to divide this by 7. Again, make these numbers multiple, the nearest multiple of 7. So 49M minus M minus 7 plus 1 over 7. I know this is kind of a lot of work, but I don't know how else to do this systematically. So again, I need a value of M for which A is an integer. The first one is M equal to 1, which is what we actually found earlier. If you place 1 here, this would be 0. So that's 6. That's the value I already had. I just need the next one because for insufficiency I need to show there are two distinct values. The next one for this to be a multiple of 7 would be when M is 8, because this would be 8 minus 1 is 7. So M is 8, A would be 7 times 8 minus 1 minus 7 over 7. So this is 56 minus 1 is 54. So that's the next possible value of A. And if we go back here, A is 54. You will get the corresponding value of A. 7 times 54 plus 6 over 48. This is going to be an integer, and you can test. 378 plus 6 is 384. That is, let's see, 8, I think. 8, 4, 6. Yep, it is. So this number is 8. That comes out to be C is 63. So I do have two distinct values. I know it's a lot of work to do this, but you can't take a chance because sometimes they add some constraints where A and C are integers and you get just one value. So 2 alone is insufficient. If you combine 1 and 2, I have a unique value of A from here. We can compute that 0.9. It will be consistent with what we have earlier. This is divisible by 9. 9 times 3 is 27. 9 times 3, so it's 330 over 55. 11 times 5, 30. A is 6. That was that first value. So we know that if you combine 1 and 2, A is 6 and C is 8. We do know the number of children. We have a unique value. So 1 and 2 combined are sufficient. The answer is C.